The responders that we have are hooked up to a program called Cow Scout. This Cow Scout system operates from an antenna on the dairy. The responders transmit about 1 kilometre to the antenna, and that information about their activities relayed back to the dairy I'm not sure how often, but regularly. If the cows are further than 1 kilometre from the dairy, as they walk up to the dairy, the information is downloaded onto the computer so that we have that information available to us by the time they get to the dairy. It's all stayed on our server here, and also it's also transmitted to the house by Wi-Fi, so my wife who does the records can do that from the house instead of having to come over to the dairy. She can do it from the farm office in the house. And also the Cow Scout is transmitted to the internet, so I can pick it up on my mobile phone through an app, and I can monitor my cows when I'm a long way away from home. So it's all a very good system. Yeah.
This is one of the sensor units that we're using for one of the body segments. As you can see, it's very small to be attached to the body, and also it's very lightweight, that don't make any difference in the patterns of gait cycle. Also, the system designed to be communicate with the receiver dongle wirelessly and without any wire connected, so it gets powered from a battery inside the box, and the battery should be charged before the data get captured. And this is a type of battery we're using, a small lithium battery. A fully charged battery can make the data collection possible for about 24 hours continuously. We have 3 separate devices like this one that's sending the data at the same time to a receiver dongle. This is the receiver dongle we're talking about. And this receiver dongle will be connected to the computer directly. The data from all 3 sensors will be come to the receiver dongle and recorded through the serial port to the computer as a .csv file for post-process stage. This is what's inside the box, a processor. In our case, we're using an Arduino processor, and also a RF communication section. This connects through some small little wires inside the box, and the data all captured through the RF section will be sent to the processor for collecting and sending through the serial ports or USB ports to the computer. So what currently sensor is doing is sending the data to the receiver dongle, which should be maximum 10 meters away from the subject and sensors. But in future, we're planning to have a device that can collect the data and send it to a smartphone or any other device that can collect the data and send it through the internet.
So the communications that we are exploring are Bluetooth, Wi-Fi, Bluetooth low energy, and then LoRa communication networks, and Zigbee as well. Now you can buy development kits off the shelf and put them together very simply. They all have their different advantages and disadvantages. They all have their different power requirements. But yeah, the communication systems for those, it's almost getting to the stage where it's kind of industry standard. In the past, we have developed our own antennas, for example, for particular wavelengths, but now you can just buy them off the shelf and use them. So different types of communication systems that you can use.
So the sensors that we see over here, the LiDARs and the cameras, are actually plugged in directly to the systems on board. In addition to that, we have GPS, 4G, 3G, radio and Wi-Fi, which connect wirelessly to networks around campus to aid its location positioning.